Welcome back everybody, Mr. Allen here. I'm going to go through question 6 from the permutations with duplication section. I think it's a good question and it's got a couple of restrictions on it, so it's probably a helpful one to look at. So the two restrictions, essentially, my numbers must be even. Wow, that's a nice straight line. And they must be smaller than 5 million. Let's take those out. That is to say, I'm counting any numbers that can be made using these digits that are both even and 5 million. So if I tried to put these numbers together in exactly the format they are, 3, 4, 4, 5, 7, 7, 8, I would have a number which is both smaller than 5 million and even, so that would be 1. If I flip-flop this 4 with the 3 and I had 4, 3, 4, 5, 7, 7, 8, fantastic. There's a second number that is both smaller than 5 million and even. And if I continued that process and just tried moving numbers around, I would realize, oh no, this one is an odd number. It is not smaller, or it is smaller than 5 million, but it's an even number. Sorry, it's not an even number, so I don't want to count it, and so on. So essentially, I'm looking to count all the different numbers in the millions range using these digits that are both smaller than 5 million and even. Obviously, I don't want to list them, so we have to sort of systematically go through this. So I have 7 different slots here. For the number to be even, I realize it's going to have to end with a 4 or an 8. So essentially, I'm going to use one of my 4's here, or my 8, meaning I have 3 options at this point. The other restriction is the first number must be a 3, 4, or 4, so I'll kind of jump to that spot because it's easier to deal with the restrictions first here. So now I've used a 4, 4, or an 8 over here, which means I have, so I'm stuck. Recognize that if I've used my 8, I have 3, 4, or 4, 3 options available to me. If I used one of my 4's though, I now only have 1 4 remaining, 1 3 remaining, meaning 2 options. And as soon as I get to that point, I should recognize, or I have to recognize, I'll learn to recognize that I can't solve this question in one step. I basically have to treat the two situations, the two cases, if you will, separately. So I'm going to backtrack here, start again, and see what happens. So my options for my final digit again, I could use the 8 or I could use the 4's, but depending on which one I have, I end up with a different next step to do. So let's see what happens if I put the 8 here. There's only one way where I could do that. There's only one 8 available, so there would be one available slot for that, one available digit for that slot. Now I have 1, 2, 3 different values up front, potentially up front. I could have a 3 or either of the 4's, meaning I have 3 different ways to choose that digit. Once I've chosen one of those, 2 of those remain. The 5 is still available, the 7 is still available, the other 7 is still available, so there are 5 numbers available for this spot. And then as I use up one number there, I'll have 4 available, 3 available, 2, and 1 in those remaining positions. So again, this will be a 3 or a 4 depending on what was used here. The remaining 4 or the 3, or one of the 2 4's if the 3 was used up. But there are 5 possibilities here. 2 from here, and then the 5, 7, 7. And again, whatever was used up now is not available here, but the 4 that were not used are still available, and then 3 and so on. And then as I go across, of course, recognizing that in order to find a number that is both smaller than 5 million and even, I need to have this digit established, and this one, and this one, and this one, which means I will be multiplying all my values across. And so I've got 3 times 5 times 4 times 3 times 2 times 1, so that's 3 times 5 factorial, which is 360. Now, following the exact same arguments for the second part, my number could also end in a 4. And if it ends in a 4, I have two different 4s from which to choose. So my number ends in a 4. It could be this 4 or it could be this 4. Now I recognize that the numbers we get will be duplicates as a result of that. If I put a 4 there or I put a 4 there, obviously that doesn't change the actual numbers that I'm looking at. But as was the case in all the duplication questions, I'm going to solve the problem as if there is no duplication and then take the duplication into account. So one of my 4s is used up. That means I have a 3 or a 4 remaining. So I have two possibilities at the front. Then again, one of these is still available here, along with the 5, 7, 7, and the 8 that I have not yet used. And so once again, there will be 5 options here, 4 options here, 3, 2, and 1. And this is, if you can sort of see here, I've got a 2 times a 2 times a 5, 4, 3, 2, 1 being a 5 factorial, sorry. So I've got 4 times 5 factorial. Just sort of noticing the shortcuts because it helps us a little bit. That is 480. And so I have 360 solutions that use these digits and end in 8 and will be smaller than 5 million. I have 480 numbers that end in 4, are smaller than 5 million, and use those same digits. And so I will add those two solutions together and find that there are 840 solutions that I found using these digits. So what this 840 represents now is the answer to essentially this question without duplication. So it would be like having maybe a 2 here, another even number that is going to give us values less than 5 million when used as our first digit, and maybe a 9 here, an odd digit that can't be used in either the first or the last spot. That's the 840. So it's how many ways can we get an even number less than 5 million using those digits. Because of the duplication now, I have a little bit more work. But it'll be the same as the work we've always done. So the 840 again represents no duplicates. So I'm going to take that value with that represents no duplication, divide by the 2 factorial because of the double 4s, and then divide by a 2 factorial again because of the double 7s. And so that 840 divides by 2 divides by 2, 210 possible numbers that are smaller than 5 million, even, and using exclusively these digits.